Okay, so in this video, we're going to be talking about how to derive the law of sines, and I already have a triangle drawn out here. So when you're deriving the law of sines, all you have to do is draw a triangle, and I drew a triangle ABC, as you can see here. And in this triangle, you can see that I have an altitude. I have an altitude of h, and again, that altitude is going from angle C to the opposite side, being side C. So you can see that I'm forming perpendicular lines right here. And as a result, I'm going to have 90-degree angles on each side of that altitude. And again, we're calling that altitude h for the height of the triangle, okay? So that's all I've done so far. I've drawn in a triangle and I went ahead and drew in an altitude from angle C going to the opposite side, being side C. And again, you could have drawn in this altitude from any one of these vertices. I could have done it on angle B. I could have done it on angle A. It will not matter. I just went ahead and did it on angle C. So now that we have 90-degree angles and we have two right triangles, we can go ahead and write out sine of an angle. So for example, I'm going to start with angle B. I can say that sine B is going to be equal to, well, we know that sine is opposite over hypotenuse. So opposite would be h, and my hypotenuse would be a. So sine B is going to be equal to h over a. So I'm going to write here h over a. So h over a. And now I'm going to go ahead and do angle A. All right, so sine of angle A is going to be equal to, again, opposite over hypotenuse. In this case here, it's going to be h over b. So h over b. So now I have two sine ratios written out. And what I want to do is solve for h. I want to solve for that altitude. So using the first one, all I have to do is multiply by a. And I'll get h is equal to a times sine b. If I do the second one, I have to multiply both sides by b, and I get h is equal to b times sine a. So what do you notice at this point? Well, I have h is equal to a sine b, and I also have h is equal to b sine a. So what I'm going to do at this point, I'm going to set both of these equal to each other, and I'm going to go ahead and rearrange it. So for example, I'm going to say here a sine b is going to be equal to b sine a. And from here, all you want to do is divide out the a and divide out the b. So for example, divide out the a. This will cancel. I also have to divide here by a. And also divide out the b. So dividing out the b, that will cancel here. And then dividing here. And you're going to be left with sine b all over b is equal to sine a all over a. Okay? So this is 2/3 of the law of sines. So if you're familiar with the law of sines, we actually have 2/3 of that formula already derived. Okay? Now from here, we have to get the other 1/3 because technically there's one more ratio that we can find here. So let's go ahead and look at the next page. So I went ahead and already wrote out these ratios. You can see them right here. Okay, that way we have them. And now we want to go ahead and find one more ratio because there is one more that exists. And remember, we did not do this for angle C yet. So I'm going to set this up for angle C. And notice what I did with the triangle. I no longer have that altitude going from my angle C. I now drew it from angle B. So now I have that altitude going from angle B to the opposite side, being side B. I need to do this so that I can find the other variation of this ratio, okay, that we're looking for. So again, if I were to leave this altitude like I did in the first problem, there's no way for me to find that last missing ratio, okay? So we have to change the altitude in order to cover all possibilities, okay? So I'm going to do this for angle C now because we have not done angle C. And I'm going to say sine C is equal to, again, opposite over hypotenuse. Well, that's going to be h over a. So h over a, I'll say sine of angle A is equal to, again, opposite over hypotenuse. That's going to be h over c. So again, we're going to solve for h, and then we're going to set them equal to each other. So solving the first one for h, we get h is equal to a sine c. So a sine c. Solving the second one, we get h is equal to c, and then sine a. So from here, we want to set them equal to each other. So a sine c is going to be equal to c sine a, okay? And I just want to reiterate, this is a lowercase c, this is a uppercase c, just so we're on the same page, okay? And we're going to do the same thing that we did in the other problem, and we're going to divide out, except this time we're going to divide out a, and we're also going to divide out c. When I do that, what happens? Well, again, you're going to divide here by c, that will cancel. I also have to do it on this side, okay? And I also want to divide out a. So dividing out a, this here will cancel. I have to do it on the other side. So we get a here. So finally, I'm left with sine of angle C all over C equal to sine of angle A all over A, okay? So what do you notice here? Well, go back to the other two that we already found, and you can see that I have right here that sine A over A is equal to sine B over B. But I'm also saying right here that sine A over A is equal to sine C over C. Meaning we have three different ratios here that we can set equal to each other because they are in fact all equal to each other. So why don't we go ahead and do that? So writing out the final formula of the law of sines, we're going to have sine A all over A equal to sine B all over B equal to sine C all over C, okay? And so that is it. That is how you derive the law of sines. I hope that you gained something from this video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.